Good morning, guys. So we're going to do a quick review of what we talked about last period, and then we're going to start developing our rules for multiplying powers of the same base. So for the first one, we have a to the negative fourth, which is our definition in our textbook, kind of negative exponent. So that's going to be 1 divided by a to the fourth. For the second one, we have 7a to the negative third. So we said that's really 7 times a to the negative third. So 7 has a denominator of 1. A to the negative third is 1 divided by a to the third. So when we multiply this across, 7 times 1 is 7. 1 times a to the third is a to the third. So we get 7 divided by a cubed. And then with the last one, and we could use those rules we developed, right? We said the coefficient ends up in the numerator. Positive exponents end up in the numerator. Negative exponents end up in the denominator, but we make the exponent positive. So if you want to use those rules, that's probably a good idea. For number 3, I've got 3, which is 3 with a denominator of 1. I've got a squared, which has a denominator of 1. And b to the negative fourth is 1 divided by b to the fourth. So when I multiply my numerators and my denominators, just like my rules would have predicted, my 3 and my a squared end up in my numerator, and my b to the fourth, I make the exponent positive, it ends up in our denominator. Now the other thing we did was we talked about how we can express each of these without the fraction bar. So how did c to the fourth get to the denominator? Obviously we had c to the negative fourth. Now what about number 5? Well, a to the third is perfectly fine as is. How did b to the fifth get to my denominator? I would need to use a negative exponent. And the same thing for 6, right? The 4a is perfectly fine. How does b get to the denominator? To the first power, I use b to the negative first power. Now, hopefully what we do today is a review where we're going to learn how to multiply powers of the same base. So just as a refresher, when we have an expression, okay, or even let's make that a little bit simpler, we have what's called the base, and we have what's called the power or the exponent, right? So the base is what's being raised to the power. So how would we express x to the fourth times x to the third? What should we do with the exponent? Should we add them, subtract them, multiply them, divide them, or maybe something else? Well, let's see. Well, if I expand x to the fourth power, that's 4 powers of x. And if I expand x to the third power, that's 3 powers of x. So if I count those up, I've got 1, 2, 3, 4, 5, 6, 7 powers of x. And I can do the same thing numerically. I've got 3 times 3 to the fifth, which is 5 powers of 3. So I've got 1 3, and I've got 5 more 3s. Altogether, I have 6 powers of 3. And we should also be able to make the connection that 3 without an exponent is really an exponent of 1. So I'd say this is pretty good evidence that we should be keeping the base and adding the powers when we multiply powers of the same base. And that's what we're going to put in our notes, right? That when we multiply powers of the same base, we keep the base, which in this case is x, and we add the exponents, right? So we keep the base of x the same. We add 2 and the 5, and we get 7. Now this will only work if we have the same base. So I can't do anything about this because I've got different bases, and we will see this. But just to be clear, we're only going to add the powers of the same base. That's why it's bolded and underlined. So let's check out this first one. I've got the same base, which is 4. So I keep the base, and I add my powers. Right? Because if I wrote this out, I'd have 6 powers of 4. I'd have 4 powers of 4 is 10 powers of 4. Hopefully we know that 9 is 9 to the first. So when I keep my base and add my powers, I get 9 to the 9th. For the next one, we can't do anything. Okay? It says simplify the expression if possible. So we would say, I was going to say not possible. We're going to say already in simplest form. And for the next one, I have negative 5 in parentheses to the third times negative 5 in parentheses to the 11th. So I'll keep my base and add my powers, which should give me negative 5 to the 14th. All right, nothing different here except the fact that we've got some negative powers. So I'm going to keep my base, which is a, Negative 6 plus 9 is 3, so a to the third. This one gets a little tricky. So c has a power of 1. So what's c to the first times c to the negative fifth? Well, 1 plus negative 5 is negative 4 times a to the third. Can I go any further with this? Well, I guess I can write c to the negative fourth as 1 divided by c to the fourth times a to the third divided by 1. So yeah, I can write this as a fraction a to the third divided by c to the fourth. The next one, both of my exponents are negative, so when I add those powers, I get y to the negative 13th. In general, we don't leave a negative exponent. We would much rather write it as a fraction. And guys, I realize I'm going a little fast here, but the good thing about the videos is we can always pause and we can take some notes and we can go back. So now I've got c times a to the third. So I know that a times a to the third is a to the fourth c. So we're just going to write it like that, a to the fourth c. All right, so I've got, if I wrote this out, if I was doing expanded form, I'd have c times a to the third, which is a times a times a. So what do I have? I have a to the fourth, but I've also got c. So we're going to write it like that. You don't need a multiplication dot, just put the terms right next to each other. What about this one? Well, all of my powers are different. So the only thing I can do is I can rewrite them as fractions, right? So a to the negative fifth is 1 divided by a to the fifth. B to the seventh, of course, has a denominator of 1, so does c to the third. So I get b to the seventh, c to the third, divided by a to the fifth. All right, let's see about this one. So I've got a to the fourth times a to the negative fourth. That's a to the 0. I've got b to the second times b to the fifth. That's b to the seventh. So let's be careful, right? That doesn't make the whole thing 1 just because I have an exponent of 0. A to the 0 power is 1, and 1 times b to the 7th is b to the 7th. So what happened to a? Well, a became a to the 0, which became the number 1. So we don't write 1b to the 7th. We could, I guess. We simply write b to the 7th. All right, missing power. So a to the fourth times a to some power is a to the 11th. Well, if I know I'm adding the powers, I can basically make an equation. An exponent of 4 plus an exponent of question mark is equal to 11. Well, that should be pretty easy then. I'm sure most of us were able to figure out that this was going to be 7. Because a to the fourth times a to the 7th is a to the 11th. What about the next one? Well, I'm going to do the same thing. I'm going to say 5, right, plus what is equal to negative 3. So I could drop a variable in there if I want. And we should be able to figure out, even without the algebra, that x is negative 8. In other words, what can I add to 5 to get me all the way back to negative 3? Well, negative 3 is 8 units to the left of 5 on a number line. So that means I would have to use negative 5 because 5 plus negative 8 is negative 3. All right, guys, so this is our now try. So you would, of course, pause. And then we come back and we share. So keep the base of 7, add my exponents. 4 plus 5 is 9. For this one, I've got r to the first times r to the fourth is r to the fifth. S to the 10th is going to stay as is. For the next one, I really can't do much with it. I mean, the only thing I can do is I can write it as one term without the multiplication dot. For the next one, I've got 1, 1, 1. So 1 plus 1 is 3, plus negative 5 is negative 2. And I can rewrite that as 1 divided by c squared, if I want to write it as a fraction. For the next one, the bases, I've got 3 to the 7th times 3 to the 3rd. Keep the base, add the powers. 5 to the 12th times 5 to the 5th. Keep the base and add the powers. That one I'm probably going to want to use a multiplication dot just to separate the bases since they're numerical. And let's look at this last one. A to the 6th times a to the negative 6th, of course, is a to the 0. B to the 5th times b to the negative 5th is b to the 0. And since a to the 0 is equal to 1 and b to the 0 is equal to 1, my product just ends up as 1. All right, little extension here, guys, so a little extra. What would happen if the powers are variables? Now this is, like I said, this is more of like a 9th grade type application. Well, I'm going to keep the base and I'm going to add the powers. So it's x to the a plus b power. All right, probably should use parentheses there, but it looks a little odd, so I'm going to leave it like that for now. X to the a times x to the third. Keep the base, add the powers. So it's x to the a plus 3 power. Let's take a look at this next one, right? So 3 to the 5th times 9. Well, on the surface, I don't have a common base. But what is 9 equal to? 9 is equal to 3 times 3, which is the same as saying 3 squared. So I can actually rewrite the number 9 as 3 squared. So now I've got 3 to the 5th times 3 squared. Well, that's easy. I keep the base and add the powers. And this is the same as saying 3 to the 7th, right? Because 9 is 3 times 3. So I have 5 powers of 3 multiplied by 9, which is 2 more. That's going to give me 7. Let's think about the next one in the same lines, right? What is 16? 16 is 2 times 2 times 2 times 2 times 2. It's actually 2 to the 4th. So I can replace this, or I can rewrite it using an equivalent expression. And 2 to the 3rd times 2 to the 4th is 2 to the 7th. So since 16, right, is equal to 2 times 2 times 2 times 2, we'll call that 2 to the 4th, times 2 to the 3rd is 2 to the 7th. Tonight's homework is actually going to be a worksheet, all right? So you'll see the worksheet up on Google Classroom. And you're going to complete the worksheet and upload a photo as always. Any questions, comments, or concerns, post your work and ask a question on Google Classroom.